So this is just our little itinerary that I made for today. You can see up here. So for the first thing, I'm gonna speed up our player because our player's really slow. I'm gonna show you how to deal with key pressed. So instead of moving the way we currently do, where I hit W, A, S, or D, and then I'll keep moving in the direction indicated, I'm only gonna move if the key is down. So I'll stop automatically if the keys are up. And then we're going to look at shooting with the mouse click in any direction. So let's jump right in. So the very first thing I'm going to do is I'm going to speed up the player right here. I'm going to double the player's speed because they are quite slow. Now, because I'm doing this in the class square, all the different objects that we create, including the bullets and enemies and the player, are all going to have this faster speed unless we change it when we create them. So I'm going to scroll on down here and look at where bullets and enemies are created. So when I click the spacebar, I fire a bullet, and I default set that speed to 10. So let's actually make the bullets even faster. Let's make them 20. See if that's not too fast. And then down here is where I'm spawning in enemies, and I'm not changing their speed at all. So I'm going to go ahead and make sure I'm setting their speed to be 10. Now at this point, the fact that I'm putting in at least two different speeds tells me that I should probably just add an argument to the constructor of square. So even though I started it and I already just put in some of that work, I'm just going to actually go ahead and do this, because it's clear to me once I've set too many of those individually that I should just go ahead and put it as an argument to the constructor. So the player's speed will be 10 right here. And then when I create a bullet, I'm going to put in its speed as 20. And I won't need to set its speed there anymore. And when I create the enemy itself right here, I'll set its speed as 10. So it'll be still kind of slow. So I eliminated 2 lines of code there and just had to add an extra parameter, an extra input to the constructor. Let's go ahead and run this and make sure everything is as expected. Here I am on the screen. I move a little faster. Bullets are pretty fast as well. And the enemies come down at the same speed they did before, but now I'm a little bit faster. I can actually handle it a little bit better. So that's the speed up. That makes things a little bit easier right there. I'm going to go over to a web page and grab a little piece of information. And just so you know what web page I'm using, maybe you want to look at it. I'm using this nerdparadise.com/programming/Pygame, and part 6 is the one that Google linked me to when I was looking up how to do the key pressed stuff. So now I'm going to scroll down to where I'm dealing with user input right here. And the way I was doing it before is I would set the direction of movement with the W, A, S, or D keys right here. I'm going to comment this out so that I'm no longer using this mechanism. So my W, A, S, D keys are going to do something different. I'm going to do this a little bit differently. I'm going to scroll down and I'm going to make sure that I'm not in this for loop. All right, so I'm going to scroll down here and I see that this is outside the for loop. So handle held down keys is what I want to do. So I'm going to still fire bullets just when I press the spacebar. So I need to press and release the spacebar to fire another key. But for the held down keys, I'm going to use something called pygame.key.getPressed. And I'll just put this, so it's a list. This gives you back a list of which keys are held down. I'm just going to name that list pressed. And then I'm going to access that, and I'm going to say like if pressed bracket, and now I have to use a particular key, and there's special names for each key. So the tab key is like this. So like if I hit tab, I can respond to that. You know, I could move in a particular direction. But I'm going to change my direction system a little bit. But here, if I press tab, I'll move north. I don't want the tab key though. I want the W, A, S, and D keys, and conveniently they're actually just named pygame.K_W. And then I can do the same thing with A, S, and D. So there's A, there's S, and there's D. And now I want the object to move when I'm holding down one of these keys and go in the particular direction that I'm dealing with. So I'm actually going to take this square.move, I'm going to cut it, and I'm going to pop it up under this W key right here. But we're going to change move a little bit. Or actually, we're going to create a different version of move. Because currently, move just checks the direction that I'm facing and moves me in that direction. But I want something slightly different. I want something that I'm going to call MoveDirection. So I need to start with self. This belongs to any object of type square. And then I'm going to pass in a direction. So I'm just going to tell it what direction it's going to temporarily move in. It's not going to like save the direction to its self variable. It's just going to like for one frame move in the direction that I told it to. And I'm actually going to copy and paste all this code. So this is going to be convenient to use. And I'm not going to check if self.direction equals east. I'm just going to check if this direction variable equals east. So this is checking the direction variable that I passed in. That is a different variable from self.direction. It doesn't belong to an object of type square. It's just an argument that was passed into the function right here. So now I can pass in east, west, north, or south, and I will move in the direction that I want. So let's test this out with our new WASD right here. So square.MoveDirection, and the W key is north. Quickly fill all these in. Right, so now my movement should only happen when the key is held down, right? I deleted the player.move from down here, and now I've got this new function called MoveDirection. And you can see that now I'm able to stop moving. You can probably even hear if I click it loud enough that I'm releasing the key. And if you're doing anything where you want to deal with those held down keys, this is the way you're going to want to do it. So dealing with held down keys, you want to use this nice line right here, this pygame.get that .key.getPressed. It gets a list of all the keys that are held down, and then you just check if pressed, and then you give it the name of the key you want. So there's a whole bunch of keys that are capital K underscore, and then just whatever letter you want on the keyboard. You'll have to look these up. I think like left is like the arrow key. Actually, I think is it lowercase or is it not? It looks like it's actually capitalized. So I get the autocomplete here, so I can see which keys are available. But like all caps left, right, up, or down will be your arrow keys. Space is going to be the space bar. All kinds of options there. But I'm going to stick with the WASD. That's convenient for me. All right. So that's the key pressed stuff right there. And actually on that same Nerd Paradise page, it gives us the first thing that we're going to want for the shoot in any direction. And that first thing that we're going to want is getting the mouse position. So when I click, I want to be able to find the mouse position. What I'm going to use for that is pygame.mouse.getPosition. All right. So key down is an event for when I press a key. There's also an event for when I press the mouse down. So that is the event mouse button down. So jump back into my code there. So I'm going to say if event.type pygame.mouse button down, I'm going to get the position of the mouse. I'm just going to copy and paste it again from up here. And for starters, all I'm going to do is print this out. So this is going to give me an XY coordinate. So I'll say x comma y equals pygame.mouse position. And then I'm going to print out these XY coordinates on the screen just to see how that looks. We'll test that out. So I'm clicking around and I'm actually not getting any response here. All right, so if event.type, oh, my indentation is bad. This is a really common mistake, especially when all this event handling gets kind of nasty. So notice how this indentation right here, if I scroll directly down, this is indented inside of the checking for the key down event. It's not what I want. Separately, I want to check for a different type of event, the mouse button down. This is one of the reasons I recommend putting all your event handling in its own function so that this indentation doesn't just get out of control crazy. All right, so I unindented mouse button down. Now it should work for me. I'm actually not going to share the screen. I'm just going to run it, and you should see in the console that I have numbers showing up, right? So you see these numbers down here. So our next thing is to actually send a bullet off in that direction, towards those XY coordinates. We're going to have to change up our square a little bit. I could simply add in the variables that I want, but I'm going to show something a little bit more advanced today instead. I'm going to show something called inheritance. So this is where I create a class, and I'll call mine bullet. And it's going to inherit from another class. And what that means is it's going to have access to all the abilities, and so all the functions, all the variables that the square knows about, but it might know about some more things. It might be more specific in a few ways. So that's the idea of inheritance. You have a parent class and a child class. In this case, the parent is the square and the child is the bullet. And the bullet's going to be more specific. I'm still going to have an init, a constructor for my bullet class. And honestly, I'm just going to go back up and I'm going to copy and paste in all the arguments. I'm going to want all these same arguments, but I might want some extra arguments, some additional information in order to create a bullet. And specifically, I want these things that I'm going to call dx and dy, but not all as one. Two different things, dx and dy. These are going to be my change in x and my change in y. It's going to tell me what direction that I'm going to move in. The d stands for delta. A physics class, this might be more familiar. It's just change in x, change in y. All right. The very first thing that I'm going to do that's going to look a little weird is for this inheritance. Actually, before I go to this, notice I put in parentheses square right here. Now, if I go back up to the square class, it doesn't have any parentheses right here. None at all. That's because square does not inherit from any other class. But by using the parentheses right here, I'm saying bullet is going to inherit from square. Other thing that's going to be different is I'm going to say super dot underscore underscore init. And what this is saying is we are going to ask our parent, which is of type square, to call its constructor. And this is how we're going to get access to all of its variables, all of its functions. We're going to construct the square sort of inside of the bullet, and we're going to gain all of its powers. I need to pass to the square all of the arguments that it needs to construct a square. So I just pass those right along. I'm just kind of creating a pipeline here, straight from the bullet right into the square itself. I'm not passing in dx and dy because the square doesn't use dx and dy. That's what's going to be special about the bullet. Self.dx equals dx, self.dy equals dy. And actually, as I think about this, I'm going to change this a little bit. I'm going to call this target x and target y, and I'm going to calculate the dx and the dy. So I'm still going to use these. We'll get back to these later. I'm going to calculate the dx and dy based off of my target x and my target y. So that'll send this bullet in the direction of whatever I clicked on. So I can just pass the mouse location that I want to shoot at in as arguments right here. Now, just to test this out, I can actually stop right here. And this is enough to create a bullet object. When I click the mouse button down, I want to create this bullet. I just copied where I was creating a bullet before, but now it's not a square. It's actually a bullet. It's a different thing. So it has the type of bullet. We can keep them red, and we can leave, let's see, spawn X. Oh, I calculated spawn X. Yep, we're probably going to want that spawn X, that same location that's sort of centered in the player itself. Actually, I'm going to show you something else that we can use. So square.rect.center X. We're going to use center X instead. And this might have been the better way to do it yesterday. I just forgot that this was available. So we're going to use the center X and the center Y of our player. We'll keep the bullets the same size. But now we need to pass in dx and dy. Or, no, sorry, I changed that. My autocomplete here is helping remind me. Target X and target Y. And I'm just going to pass in literally the X and Y locations that I clicked with the mouse, because that's what I want to shoot at. That's how I'm indicating that I want to shoot there. So after this, we will append the bullet to the same bullets list as before. Right? So right there. And let's see what happens. Mostly I'm running it right now to make sure that it works. I am not thinking that this is going to be the final version. I haven't told it how to send the bullet in a particular direction, right? All I've done is set it up so that I'm prepared to do that. Now, if I click, okay, it's different from if I press the space bar, but it's not the right behavior, right? It sends the bullets off to the right. The reason it's doing that is it's just using the default direction for a bullet, which is to the right. Because like I said, I haven't actually pointed the bullets in the right direction yet. So how do I do that? How do I point the bullets in the direction I want? I passed in the information, the target that I want them to go towards, X and Y right here. And the way I'm going to do it is I'm going to use this DX and DY. And the DX and DY are going to determine how the X location of the bullet should change, how the Y location of the bullet should change so that they head off at an angle. The first thing is we want to know what is the angle that we're headed towards. And we're going to use a function that's a little bit advanced. It's called, well, it's short for arctangent, this atan. And I'm going to use the second one. You can use the first or second one. I use the second one for some reason more frequently than the first. So atan2 is what I'm going to use. And what I'm going to pass in here is target y minus my y value, my location, and then target x minus my x value right here. This is the change in the y values over a change in the x values. That should sound familiar. That is rise over run, right? We're talking about y2 minus y1 over x2 minus x1. This is slope. We are getting the slope that's going to send us towards the target. And we're getting specifically the angle of that slope. So if you imagine a straight line, the angle of that line to the horizontal, like to the x-axis, is going to be given by this function right here. And it's going to be in radians. So get angle to target in radians would be a good comment. All right. You might think, oh no, radians, that's going to be hard to deal with. I don't like it. Well, a couple things here. First of all, we can print it out in degrees very easily. So angle times 180 divided by math.pi is going to give our angle in degrees. So angle in degrees. So if we want to know, we kind of want to debug and check, are we doing this right? This could be very helpful. And I just know from experience, making this a little bit easier to read. Let's make it an integer, because otherwise the decimal is going to be out of control long. This will just make it a little bit easier to read. But we don't actually need to put it into degrees or anything like that, right? This line of code does not change the value of angle. It just prints it out just to see. If we want to get how our x should change, we're going to use math.cosine, which is a little bit more familiar than something like an arctangent, I hope, at least to many of you. So cosine of the angle is going to give us our change in x. For the y value, we're going to use sine of the angle. I spell it right. All right. So let's go over to the whiteboard for a second. All right, here's me. And here is my target. There we go. There's my target. And I want to fire a bullet in that direction. All right, so I want to fire a bullet from here to here. What I'm going to do is I'm going to take my bullet, which is a square. I'm going to create it. And I'm actually going to create it right in the middle of my player right here. And I want to move it towards the yellow. And the way I'm going to do that, I'm going to change the x value by a certain amount. And then I'm going to change the y value by a certain amount. And you can see that I formed a little triangle. The length of this bottom part of the triangle, the horizontal, is going to be dx, that dx variable that I created. The height of the triangle is going to be dy. And so if I change the x this amount and I change the y this amount, it's going to look like the bullet moves along the diagonal. If I do that in this way, I know that it's going to move very slowly because I'm actually calculating the triangle with respect to the unit circle of radius 1. So I'm just going to create another variable. Oh, wait, no, I have a speed right here, don't I? Perfect. We're going to multiply these by speed. Great. So now our bullet's going to have a dx and dy that is, if you imagine a circle of radius speed, That's what we're looking at right here. Now, still, if I run this, I'm not even going to try because I know that this bullet is not going to move off at an angle because all I did was record the value of these two variables. I haven't actually used these variables at all. We should get our own move function. So here we have the move function that like the enemies are going to use and those like basic bullets are going to use. We should create our own movement function that's going to be a little bit different. So I'm going to say self.rect.x is going to equal self.rect.x. I'm going to add self.dx. There's going to be a minor problem with this. Actually, there's going to be a semi-major problem with this, I realize. All right, that's okay. I'm going to deal with it in the simple way first, and then we'll clean it up later. I'm going to make this an integer. This is going to like muck things up a little bit. It has to be an integer. Like this line of code will give an error if I don't make it an integer, but it'll reduce my accuracy because I really want this to be a decimal. But that's okay. Let's start it off as an integer, and we'll fix it in a second here. So my move function is actually a lot cleaner, right? I just want to move in the x by dx. I want to change the y by dy, and that's all I'm going to do. This right here is also another example of something called, this doesn't strike me as the right word right now, but it's the word that's coming to mind. So I'm overriding the movement function of my parent class, right? My parent has a move function. And we saw like these bullets that I created with the mouse click, they moved because they used my parent's move function, right? But this bullet is a child of the square and it's feeling rebellious with respect to move. It wants to move in its own way, off at weird diagonals. So it's going to use its own move function, and this is going to override the parent function. So if I ever tell a bullet to move, it's going to say, well, I know how to move, and I don't need to look up how my parent moves. I'm going to do it my own way. So that's what this code is actually doing now. So now, if I call move on a bullet, it won't call the square's movement function. Whereas before I had this, it would have. So now I think we're actually in pretty good shape because when I click to create a bullet, I append it to the bullet list. And down here, I loop over all the bullets and I tell them all to move. This movement function is going to be different for different objects in this list because some of them are just squares and some of them are of type bullet with a capital B, not the list bullets. So I believe this is going to work. I've added a lot of code. So let's share my screen and actually verify if this is on the right track. So I'm going to click down here. Hey, look, I can shoot in all kinds of different directions. All right, I can even still hit the, oh, well, if I had any aim at all, I could hit the enemies there. Great, so I can shoot in any direction, it seems, but there's actually still a problem. And the problem is, and hopefully I can illustrate it. So here I click over here, and it looks like I'm almost hitting the mouse, pretty accurate. If I move the mouse up a little bit, well, I'm still actually hitting it pretty well. Move the mouse up a little bit. Huh. It looks like I'm kind of missing, right? Are we seeing that? Like if I move down a little bit, actually this looks like the exact same angle. This looks like the same angle as this. Now it's a slight change in the mouse, but I'm losing some accuracy, it seems. Okay, so I get a little bit of that angle, but it's not perfect. And the reason it's not perfect is because I'm rounding. When I change to an integer, I end up rounding. Oh, and by the way, angle in degrees, it'll print out right here because I had that print statement in there. Be aware, however, that the world is upside down. Let's just bounce over to the whiteboard real quick. When I say the world is upside down, what in the world am I talking about? So you got to remember with Pygame that if I rotate, so 0 degrees and 0 radians is right here. Okay, so this is 0. And 180 degrees, or pi radians, is over here. Things get weird at the other angles, right? So, you know, I'm looking at a clock here. This should be 45 degrees. In math world, it is. This is 90 degrees in math world. And this would be like negative 45 degrees, negative 90, or 270 if we're thinking about the rotation in this direction. But that's not how it is in Pygame. So in Pygame, like I said, the world is upside down. This is either 270 degrees or negative 90. This is 90 degrees down here. So the rotation, if you rotate in the positive direction, you add positive values to your angle, you're going to be rotating clockwise. If you subtract values from your angle, you're going to be rotating counterclockwise. This is a very common mistake. It's really easy to make. So just be aware of that. I just want a little bit more accuracy out of my shooting than I'm getting. And the reason I'm not getting that accuracy is because I'm rounding these to integers. And these are not integers. They're going to be decimal numbers. So how can we get a little bit more accuracy? And the way that we can do this is I'm going to create self.x, set it equal to x. I'm going to create self.y and set it equal to y. And in this movement function, what I'm going to do is, well, first I'm going to copy this code. I'm going to change x and y. I'm not going to change rect.x and rect.y. And then instead of setting rect.x equal to itself plus the dx, I'm going to set it equal to, I'll show you here in a second. I'm going to set it equal to self.x and self.y as integers. The reason I'm doing this is self.x and self.y are floats. They're decimals. I get more accuracy if I change the self.x and y and then convert it to an integer or the rectangle. So the rectangle x and y has to be integers. That's just the way the Pygame did it, mostly because it's ambiguous how you want to draw the rectangle on the screen if it's not at a specific pixel location. So rect.x and rect.y have to be integers. If I make my x and y not an integer, oh, excuse me, I meant to get rid of these integer calls right here. Then what's going to happen is I can be at the location 1/2. And sure, it's going to draw at the pixel location of 0. I'm going to round down to 0. But if I then add a particular amount, say I only add a quarter. Say I'm moving like slower than 1 pixel per frame. If I add a quarter, now my x is at 3/4. I'm still going to be drawn at the pixel of 0. But then if I add another quarter and now I'm at 1, I'm finally going to be drawn at the pixel of 1. Whereas if I'm only adding quarters or halves to my rect.x, it's always going to round down that change. So suppose I'm at location 0 and I add a half. It's going to round it down to 0 again. So the next time I try to, quote, move, it's going to add a half to the x direction, and it's going to round it down to 0 again. I'm never going to leave that pixel if I'm moving too slow. Whereas with this method, where I just have this extra x and y that are allowed to be decimals, I can move a little bit more accurately. So it might be hard to see, but I'm going to run it, and the shooting should be more accurate at this point. You can see that those squares are going right through my mouse. If I move just a little bit, they're still going right through my mouse. Move a little bit more, they're going right on through, right? And the adjustments are very fine-grained. So I should be able to shoot at any angle and go right on through my mouse. Great.